Hello, I am James Walbright, and we are Team Solar Mist. Our project is a solar-powered automated irrigation system. This project will allow the use of a center pivot irrigation in locations where traditional power sources are not accessible. I am working on the small-scale center pivot mechanism as well as the inverter specifications. The center pivot mechanism will be run using a drive motor for each arm. This motor will be powered during the evening irrigation hours through the use of a small battery storage pack. The battery pack will be described by Chris later in this video. The system will run a positive displacement pump, a storage tank, and a sensor monitoring the system. The positive displacement pump will pump water into a storage tank during times where the solar energy is present.
I am Mallory Herrera, and I am working on the sensors and the sensor programming. Our final design of the subsystem small scale takes into account a total of 5 sensors. There are 2 soil moisture sensors due to the presence of 2 demonstration day boxes of sod. Each of the soil moisture sensors will take the water moisture readings from the soil. This reading is then compared to a maximum or minimum level. If the maximum level is met or exceeded, the irrigation system will cancel until the levels are within a proper range to avoid drowning and molding of the crop roots. The wind sensor will allow for the monitoring of wind speeds to prevent irrigation during high levels. This monitoring is essential because if the wind is blowing too hard, the water will not reach the crops and will be wasted, lessening not only conservation measures, but also the ability for crops to grow adequately. The rain sensor and detector will determine the presence of rain and the amount that has fallen. The system will have a required water amount for each crop being irrigated. If this level is measured from the collector, the system will cancel irrigation. In order to improve the automation, a modified irrigation schedule has also been designed. The schedule will determine how much water needs to be delivered if rainfall has been collected but not reached the full required amount of the crop.
Good day, I am Will Warren, and I'm working with the Arduino and the Raspberry Pi to create a program for the irrigation system. I am also working on the inverter specifications with Jamie and Chris to finalize the power portion of the project. The demo day presentation will entail a small-scale demonstration consisting of 2 3-foot by 3-foot sections of sod with a center pivot irrigation system that will utilize the sensors and a main interface control. It will be introduced to various weather conditions in order to simulate the real-world possibilities. One of these simulations will be a soil saturation amount to represent the rainfall, which is equal to what the crop requires in a single irrigation cycle. This will cause the system to pause until the next irrigation cycle, at which point it will check the soil moisture sensor to verify the water needed is now needed. If not, it will again pause the irrigation cycle. Now I'll pass over to Chris, who will tell you more.
I'm Chris Rich, and I'm working on the solar panels and the overall power needs of the irrigation system. During the budget planning process of the design, the team found that the battery storage system originally planned was not cost-effective. To alleviate the high cost of batteries, the team turned to the use of a storage tank that would use gravity to deliver water to the center pivot arm. This allows the new system design to power a PVP pump during the day and use small battery storage for energy during the evening when the irrigation is occurring. When the solar panels are producing energy, the pump will route water into the elevated storage tank until the float indicator reads full. Once the elevated storage tank is filled, the system will route the energy produced from the solar panels to the battery pack. This energy can then be accessed by the sensors and drive motors during the irrigation hours.